Welcome to AI Frontiers. Today's episode is Robotics Reimagined, Adaptation, Dexterity, and Style. We're highlighting 11 breakthrough robotics papers published July 12, 2025 in the Computer Science Robotics category. We'll explore how robots sense, move, adapt, and learn, revealing their growing real-world impact, from warehouses to homes. A special focus will be given to the work of Teshome and colleagues, offering a glimpse into the future of intelligent machines. Picture a world where robot dogs run with their own unique swagger or drones hover gracefully for hours, even when visual cues are missing. Today's robotics are not simply copying humans. They're learning by observing human errors and adapting in real time. These scenarios are now reality, reflecting advances no longer confined to science fiction. This episode will uncover how modern robots are rewriting the rules of intelligence and adaptation. Robotics now blends artificial intelligence, mechanical engineering, and advanced perception, enabling machines to interact with the world beyond factory floors. Robots are entering homes, hospitals, and urban streets, facing the messiness and unpredictability of real life. Current research addresses how robots adapt, learn, and thrive in dynamic environments. In this episode, the latest breakthroughs will be broken down, making them accessible to both newcomers and experts in the field. The field of robotics, designated as cs.RO in computer science, can be likened to a conductor orchestrating multiple talents. Algorithms enable robots to perceive, plan, act, and interact, integrating mechanics, electronics, and cognitive science. This synthesis is similar to a chef balancing flavors for a perfect dish. The overarching goal is to produce robots that operate fluidly and adaptively in the complexity of human environments. Adaptive motion planning is undergoing a transformation. Traditionally, robots depended on perfect environmental maps, an unrealistic expectation for real-world scenarios. The work of Teshome and colleagues exemplifies a new approach, real-time planning using live point cloud data. This system blends the creative capacity of generative AI with the safety provided by potential fields. Robots can now adapt their routes instantly, akin to jazz musicians improvising, making navigation possible in dynamic, unpredictable spaces. A significant advance in robotics is the ability to learn style from imperfection. Robots now absorb not only the tasks demonstrated by humans, but also the individual style, including mistakes. Wen and colleagues developed methods enabling robots to learn from imperfect human demonstrations, capturing unique movement patterns. This process resembles an apprentice chef learning not only recipes but the master's personal flair. The result is robots achieving both higher efficiency and expressive, personalized movements. Robotic perception often involves working with incomplete or mismatched sensor data. Ni and colleagues developed efficient mapping techniques that handle sparse and noisy inputs, while Yi and associates addressed the calibration of non-overlapping LiDAR sensors using a dual adjustment approach. This is analogous to builders aligning a structure without direct communication. These innovations result in more reliable robot perception and improve autonomous performance in complex environments. Let's examine key research breakthroughs in action. Teshome's system allows robots to adapt rapidly within chaotic warehouse environments. Wen's techniques led to robots acquiring stylish and energy-efficient movement patterns. Stolzel and team introduced orbitally stable rhythmic motions, benefiting robotic arms and locomotion. Yes, sensor calibration enables precise mapping even without overlapping inputs. Huang's tactile VLA system empowers robots to generalize new physical tasks from minimal demonstrations using combined visual language and tactile information. The featured paper of the day is by Teshome and colleagues, which addresses real-time pursuit evasion tasks with only partial environmental information. Their framework fuses diffusion models, which provide imaginative route generation with the safety constraints of artificial potential fields. The approach operates directly on live LiDAR point clouds, continuously adapting plans as new obstacles appear, eliminating the need for a perfect map. In dynamic environments, this system outperforms traditional planning methods. The Teshome et al. System operates through a sequence of advanced steps. The diffusion model first generates diverse route options, employing classifier-free learning for flexible trajectory formation. Artificial potential fields then steer these routes away from newly detected hazards. This process occurs in a continuous loop, where the system proposes, refines, and adapts plans as sensor data streams in. The operation is comparable to a jazz musician improvising in real time, responding creatively to each environmental change. The impact of Teshome and colleagues' work is significant for the future of robotics. Their system enables safe and efficient robot navigation in cluttered, unpredictable environments. It is directly applicable to autonomous vehicles, aerial drones, and rescue robots. This research demonstrates that robots can thrive even without perfect environmental knowledge. A crucial step forward. The project was inspired by the inherent unpredictability of real-world settings and the persistence of researchers working late into the night. Ultimately, it strikes a careful balance between exploration and safety, a hallmark of next-generation robotics. Looking toward the future, robotics is envisioned as a garden of innovation, where generative models merge with classical planning to create creative, adaptable machines. The integration of multimodal sensing, combining vision, language, and touch, will grant robots a richer, more human-like understanding of their environment. Procedural task generation will provide robots with a continuous stream of new challenges, accelerating their learning process. However, open challenges persist, including real-time operational constraints, data scarcity, and ensuring the safe deployment of these advanced systems. In summary, robotics is advancing at an unprecedented pace by blending adaptability, dexterity, and style, as evidenced by research from Teshome, Wen, and others. Robots are increasingly present in daily life, tackling unfamiliar problems and environments. Major challenges remain in achieving human-level dexterity, learning from limited data, and upholding ethical standards. Audience engagement is encouraged. Your perspective and participation could shape the next breakthrough. Robotics is an open frontier, and every contribution matters. This episode has been synthesized and reviewed through a combination of artificial intelligence and human expertise. Content generation was powered by GPT 4.1, while DeepGram TTS provided audio, and OpenAI supported image descriptions. All synthesized content underwent expert human review for technical accuracy. Nonetheless, some oversights may remain, so you are encouraged to consult the primary research papers for detailed verification. Full references are provided for further reading. Subscribe to AI Frontiers for the latest updates in artificial intelligence and robotics research. Share your thoughts and questions in the comments to join an active community of experts and enthusiasts. AI Frontiers is your curated source for expert-driven insights, delivering daily developments in the field. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.